Welcome to part number 3, and I would love to introduce you, of course, to the stuff that we want to do here. This time not as an overview, this time more like a bridge or a refresher, whatever you like. And I want to refresh, of course, that overlapping just in one area is not always overlapping all over the place. And please don't take this here as a suggestion to take 220 degree of view with just 3 captures. That might work in some cases, but it's very dangerous here on these areas. And when you then have some motion blur here in it that you don't want to have, then it's maybe nice to have some more pictures of this area to get this stuff out. I have, of course, a lot of pictures from this panorama, and I have selected only 3 to show you the problems and to make clear that we have here a distortion. Did you notice the curvature here on the button is completely different than on the top one, which indicates that the camera was looking a little bit up. Okay, how is that all to understand? When we go here, for example, to a flat projection, we get a complete different picture. And that means we take now our, I would think, 220 degree view on a flat plane from one point. And then we get here these huge distortion. It's not really working here. And when we take a spherical approach, we get maybe something completely different again. And I will show you that, of course, what happens. But overlapping is the problem in any case. And then in pedagogy, we have here a lot of more to do and options. We can have even this option here, which I use from time to time for my images, not for 3D work, where the top one is more compressed than the bottom one. And you see that the curvature is much more flat. Works very nicely for just beauty images when you have high buildings in it and you don't want to have that distortion in it. You can compress this. You see here maybe the squares are different. Anyway, I want to focus on these 3 ones because these 3 are the most in use, I would say, for 3D. Again, the big gap between information and art. And you will produce art with your scene, but all the stuff that goes in it should be as neutral as possible, or it should follow your decision in the project. But it shouldn't be something on its own and then feel a little bit alienated in the scene. Okay, let's hop over to Cinema 4D, where I have prepared a simulation of that. So let's start here in Cinema 4D with the cylindrical projection simulation. And this is just to introduce you to how it works. And it is a simplified process here because we have not dealt with any lens distortion. We do not have dealt here with any vignetting or chromatic aberration or any other image things. So if you like to use this technique just to project all these pictures in a cylinder and then bake it with maybe some alpha channels here, that would work. But keep in mind that the lens distortion is then not handled. And that might be a problem. If you handle it first and then project it and then bake it, you have several steps. And these several steps degrade the quality each time. So it's always a question how much quality you want to get out of it. In pedagogy, for example, it is then used in one process. So the picture goes in and then each pixel is calculated and then we write a new picture. It's not written again, saved, and then written again, saved, and each time it degrades. It's only one time, as much as I believe this. Okay, so what we can see here is a cylindrical projection, and this is normally perfect and preferable for one row when the one row is horizontally. When it goes more up or down, like I project this now here, we see we get a lot of distortion here and we get a lot of shrinking here. That is then maybe already a consideration if we go and use spherical projection, as we will see this in the next step. What we can see here is, of course, just something that happens when we go too far with our projection. And here also one hint, so you can read what happens here with these projections. The bigger the bow here is, the more distortion we have, of course. But in the moment it is just straight here, we have found exactly the level of the camera, so you can read these pictures a little bit better. What I want to show you here, and I put this camera here back to 000, is the standard process. And I use now here a null object that sits exactly on the vertical axis here. And when you take a look, for example, to this line here, we can go now ahead and move this here around, and that would be picture number 2 of this row. And then we have here where the line is maybe exactly an option to have the seam. And the seam is then the transition from one image to the other one. And there are two main areas if you do this by hand, which sometimes is necessary, not always is automatic possible here. The first thing where we have to look out for in this area here where it is overlapping is the dark areas. There's, from my point of view, nothing better than to hide the seam in a dark area and find something here. The second tip that I want to give you is, if there is no dark area, then find something with a high frequency. Anything that has no high frequency, for example a sky or so, might cause a problem because it's more visible where you have the seam. And third, never do a straight line. It is pretty obvious when you have a straight line as seam, because that is easily recognizable and the whole illusion goes down. Better is a gradient and a more chaotic line, whatever the picture gives you as logic for the seam. So you have to understand what picture's in front of you and then work with it. That's only one hint. And so we bring it back both to 0, and now I want to simulate what happens here finally when you use freehand panoramas. And that has maybe a little bit to do with these wiggle here that I do, and that is of course now totally exaggerated, but you see already where we can go when we just use any axis as free. Nothing is restricted with a tripod or with a panoramic head. So we have to find maybe something that is now between these two images, this and this. And it becomes more and more a problem because the quality, as you can see here, changes dramatically when we move away from the eye level. The closer it is, the better the quality it is, the farther away it is, and it will be the same distance here when it is unwrapped here. This will be stretched out, so we have less quality here. So it's not really fun to go here too much into a chaotic movement. The nice thing is we want to move it here one time around, and then we have, with enough overlap, exactly what we need, and we can find the edges. We cut maybe the top and the bottom part away and we get a wonderful panorama. Okay, this is the cylindrical version here. Let's hop over to the spherical. And I switch this here on and I switch the cylinder off, as you can see that here. It's the same setup here, and I have underneath, of course, always one object that is half transparent and then the object where the projection is on, so you have maybe a better view here. So this is a complete different case, and when you remember from the cylindrical one, the higher I look up or down, the more I get a distortion here on this edge. Let's have a look what happens here now when I move this just around. It is pretty stable, isn't it? And that's the beauty of spherical. That makes, of course, not so much sense when I want to have just one row around, because then I shrink this here and then I unwrap this flat again. I'm not so really certain if I would always go just with spherical. But for the most cases, or pretty much for all cases, 360 by 180 degree, this is a nice option, of course. Also here, when I go here just into the middle and move it freely around, you see already we get something that is not really lining up all the time, and it is in a space even if projected on a sphere. Again here, freehand is a problem, and especially when you have for each exposure in the HDRI finally a different position. That's not easy to get finally back into quality. And what we have to see here as well, which is similar to the cylindrical one, when I increase here the field of view or decrease the focal length, then I get here something that looks more like a fisheye, and it has exactly this quality. We have less quality in the middle field, and we get some compressed data here on the edges. So the quality is more like a sine curve. It goes up and down and up and down. The more images we get here, the more we can maybe relay on these areas here, and we pick out the highest contrast or the highest sharpness finally. And that helps, of course, to gain good quality again. But if you have only few shots, that's not really an option. What I want to show you here as well is, and that's the same case for cylindrical one, when I have a long lens, let's say 135 millimeters here with a full frame sensor, then this image here is pretty small. So when I want to fill now here the whole sphere, the whole globe so to say, then I need for one row already a lot of images, always with a third roughly of overlapping, and then 1, 2, 3, 4, 5, and maybe down again roughly 10 rows or 9 rows if you like of these images. And of course the top row needs pretty much nearly not more than one, so to say. But what we can learn from this is, of course, the resolution that the camera provides is always the same, and the smaller the picture is, the larger the final resolution will be, and of course the quality. If you shoot in this way and then scale it down only to 50% from its original size, maybe you get something like 80,000 pixels or so from this approach, then scale it down one time means you have work like oversampling, and oversampling means here that all the pixels that have become mixed up maybe during the process, that were at one state nicely and sharp and crisp, get back to a fairly good quality. And that is of course our target. So sometimes overshooting is certainly an idea to get really good quality. And I say this with some hesitations because it's a long chain of steps that you have to do until a panorama is really done, and each step is responsible for the quality, of course. So the smaller these guys get, the more pixel quality you get, but maybe the light changes over the whole course of shooting, so sometimes there is maybe something between these super wide and these super small here preferable. There's always a trade-off between time, quality, speed, and so on. Okay, I see I have set it here nearly back to 35, and that is maybe something that is sufficient, maybe not for your project. We have discussed it, I don't want to start this again. Okay, let's hop over to the plane here. For that I have to go to the layers again and then switch off the sphere and welcome the flat version here, the plane. And the plane itself is of course something that we can use to a certain degree, and I show where the downside is. When we project from one nodal point, from one tripod, then we get a lot of distortion here on the end, and you have seen this in the first part of this tutorial, how distorted it can be. So that's not really an option. What is an option with this projection method? Because it simulates exactly the sensor flatness. So there is a relation in it. If we exclude for a moment the inability of Cinema 4D to put lens distortion out of this equation. We don't have any options here directly natively, but of course we could write maybe something, an espresso, or even with a point morph to go into the UV mesh and move them around. That's a longer story and out of the scope of this series here, but if needed I will go into that theme later on. What I want to tell you here is, normally we could think about that this plane here is attached to this axis and then it moves around. And if you have shot maybe always in, for example, 30-degree increments, you can place these planes in 30-degree increments around the camera, and then you have only to handle exactly where one plane cuts into the other one. In Nuke, that is standard procedural to create one row panoramas, for example, out of shots. So you get the pure data from the camera into Nuke and then edit everything, stitched, so to say, everything inside of Nuke with no loss of production, workflow, whatever. And that results, of course, in the need to have a special handling of these overlapping areas, which could be done in Cinema 4D with a circular gradient that has exactly here where that edge would be then the option to show what is behind and make the plane in this area where I have my mouse now transparent. So we mix these guys here a little bit. It's a little bit tricky, and as I said, out of the scope of this introduction series for panoramas, but if needed I will go into that. What I want to show you here, and that's a huge pleasure for me now, that we can take this camera here and I can show you what happens with the film offset X. And that is exactly what I have shown you in the last part of part number 2 with the shift lens. This is pretty much the optimized version of it because we have no distortion in it, and when we have handled the lens distortion, because the more we can shift, the more the lens will turn into a super wide lens with all the problems that those things have, then we can move even these pictures here in Cinema 4D around, and we don't have to go even to Photoshop and merge them. And that's the beauty here. Okay, this is only a little escape from the standard world here. We have huge tools to manipulate UV data, and UV data are a huge part as well to manipulate finally the image data, how it is finally textured on an object. And when you consider that you shoot maybe a checkerboard with any lens and you use the UV data to finally undistort exactly this image, you can use this data for each plane because any shot in this row would be then the same distortion, doesn't change just by rotating the camera. And if you have a zoom lens that has maybe on one end a pincushion distortion that looks like a pillow, or a barrel distortion on the other end of the zoom, then you could correct one and the other end of the zoom lens, and when you have something between, you can mix between that. The simplest way, and I parked this here just on another object, would be here the tags, Cinema 4D tags and character, and then the pose morph. And the pose morph has UV data in it. I will show an example what I have in mind, how it works with something in part number 3 here, of course. So this sums it up finally, and I think you got already an idea how cylindrical, spherical, or just a flat projection works. And the more you know this and the more you visualize this during your shot, the more you know what you finally need. And I think this data, how it is projected, is very helpful to know each step in the process in a better way. That is why I'm doing this here, so you get the best out of it. Thanks for listening. Have fun with it. Bye bye.